Hi everyone, welcome to Sorting Algorithms. And today we'll be doing merge sort as part of my third year project. Merge sort is a recursive algorithm. So basically, what merge sort does is essentially it divides the unsorted list of numbers into n sublists recursively until all sublists reach length of 1, which means that it cannot be divided further. Because the reason for that is because lists of length 1 is considered already sorted. The algorithm compares and repeatedly merge sublists to produce sorted sublists by calling the merge function. So essentially there's two functions that we have to worry about: the merge sort function, the merge sort procedure, and also the merge procedure. And then the merge is done until the sorted sublists merge into one final sorted list. So I'll be breaking down this slide, just the definition of merge sort, and then run through some examples with you. So before we start talk about merge sort, I would like to talk about its performance. So the data structure is the merge sort uses is an array-based data structure. The worst case time complexity is O(n) log n, which is really efficient compared to bubble sort and quicksort algorithm. Average case time complexity is theta n log n, and the best case time complexity is omega n log n. So you can see it's very consistent sorting algorithm. And the worst case space complexity is big O to n. And you'll see why in a minute, why this isn't very good. So, now I'll go through the example with you. So consider a list of numbers 4, 1, 3, 2, 5. So that's length 5. And then you notice that they have the index of 0, 1, 2, 3, 4. So that's, yep. And then what the merge sort function will do, which is the main function, will find a midpoint. So 5 divided by 2, which 5 is the length, and then 2 is just dividing it by halving the initial list, and that is 2.5. So essentially you could either round it up or round it down depending on which method you prefer. So in this case we're going to round up, so it'll be 3. So index 3, so that's where we're going to cut. We're going to split the array. So you can see there's 3 elements on this side, and then there's going to be 2 elements on this list. In this list. So when we do divide this array, we'll produce a sublist. So this is called a sublist of 4, 1, 3, and then on this side it'll be 2 and 5. And merge sort is essentially a recursive algorithm, so it calls itself. So it will repeatedly merge until the base case is reached. And I'll also talk about what the base case actually is later on. But so yeah, now you can see that this is even, so it will essentially be 2 and 5. Whereas this is also odd, so you can the length is also odd, so you can see what the algorithm will do again is calculate the length of the sublist, which is 3, and then it's divided by 2, obviously, which is 1.5, and since we rounded up before, we'll round up this time, so it will be 2. So then this is where we're going to cut our sublist. So then we get another instance of the sublist, so sublist 1, 2, and then we're going to have 4, 1, and then this side we're going to have 3. And then one final step for the merge sort algorithm is it will call the merge sort function for this sublist, but not these sublists, because this because these are of length of 1, which is considered already sorted because there's no other elements to compare to. So the algorithm will know that to stop recursively calling these the merge sort for these 3 elements. And then for this one, we are splitting it into 4 and 1. And then the algorithm will also, the merge sort procedure will stop here because it's length 1, and then it will just stop with it will reach the base case, and then no recursive calls are made. This is the end of the merge sort procedure. And then to sum up what we did here is basically this merge sort procedure cuts the unsorted list into sublists recursively in a top-down manner. So it's going down top-down manner. So from a list of length 5 to a list of 1 to the list of length 1. So it's the size of the list are decreasing. So it's in a top-down manner. And then what the algorithm will do now is the merge function. So merge sort consists of 2 functions: merge sort and merge. And what merge does is after the unsorted list is divided into elements of lists of length 1. These 5 elements, as you can see, it's the same as these 5 here, are what merge are going to be working with. So merge recognizes these elements as lists because they are just lists of size 1. What merge will do is it will compare this list containing element 4 and this list containing element 1, and then place them in a sorted order. So compare, and if they're not in the right order, it will swap. So they will place them in this new list of 1 and 4. So this list is sorted, and then what that means is the array operations of these 2 elements into this new array requires extra resources to physically move the elements into the memory locations, and then the extra memory space is required also for the new list to store these elements. So that's some things to think about when you're running this algorithm. And then this will compare as well because it's happening recursively. So 2 and 3. By comparing 2 and 3, 2 is smaller than 3, so 2 is placed in the first index. And then 5, because this list is lengths of odd, so there's no other elements to compare to, it just moves on to the next stage, really. And then the merge sort, since the merge sort is a recursive algorithm, it will now compare these 2 lists, and then it will compare. So it compare 1 and 2. 1 is bigger than 2, so 1, and then it will compare 2 is smaller than 4, so 2 goes here, and then 3 is compared with 4. 3 is smaller than 4, so 3 goes here, and 4 is the last element, so it must be the biggest one with it between these 2 lists. And then we move 5 onwards because there's nothing else to compare, and now this is where we compare these 2 lists. These are the only 2 lists remaining, so this is the new list, and then this is also a new list. So basically you can see the amount of lists there are. We're constantly creating new lists. So this is something that you have to think about in terms of when you're allocating memory for the new list, and then so it's quite resource heavy. And then finally, the merge procedure will compare 1, 2, 3, 4 with 5. So compare 1 with 5. 1 is smaller, 2 with 5, 2 smaller, 3 smaller, 4 smaller, and then 5. And then this essentially is the unsorted list. So what you need to know between the merge function and the merge sort function. Merge is essentially undoing what merge sort has done, but providing the comparing and the swapping and placing the elements in a sorted order. So it works in a bottom up manner, whereas merge sort works in a top down manner. This is the website I found. Just the website I found this merge sort code. So it's in Java, but it's very similar to the pseudocode. So first it checks for whether the right is greater than left. This just the text. This is essentially the base case, because if the right is greater than left, it means the list contains more than one element, and then this set of instructions occurs. Else, that means if left is equal to right, it means the list only has size 1, and what that means is the list should be already sorted. And then so basically this will calculate the midpoint. M is the midpoint, left plus right divided by 2. And then it will carry out 2 sort functions and 2 merge sort functions. And what it essentially is, it sorts the array from left to the middle and from middle to right. So that's the 2 sublists essentially. So this is the middle. This is left index. This is the middle index. So left to middle, and then middle plus 1 to right. And then so you can see this is a merge sort function, this is also merge sort, so it will recursively call this algorithm. And then what happens afterwards, so when it keeps recursively calling, it will keep recalculating the midpoint. So that's when I had to recalculate the midpoint here. So you can see the recursion occurring. And then it will keep doing this until the right is no longer greater than the left, which implies that. So that means that you reach this stage where all the lists cannot be further divided, and that's when you stop entering the if statement. So then what happens within each recursive call is this merge statement with the parameters of the array left, middle, and right. So if we scroll up, this is essentially the merge function here. So what it does is it calculates the sizes of the 2 sublists. This creates the sublists, the data structures for sublists to place the elements in. So this is the extra memory requirements for merge sort. And then this part is responsible for copying the data to the sublist. And then it will start merging. So it will have each individual list of size 1 that we have formed as a result of merge sorts here will have their own indices. So index of merged subarray k, I, and j. And then in here, that's when you compare the elements between 2 lists, and then placing it in a sorted order in the new list that's being created up here. So then you copy any remaining elements, which is what this is referring to, and then when merge ends, you should have the sorted list here. So this is essentially the result of merge. So that's basically how the algorithm works. Now I'll be going through the advantages and disadvantages of merge sort. Merge sort is quite a simple algorithm, so it's easy to understand. It is also a stable algorithm. So as you can see in the pseudocode, in the merge, when it's comparing, you can see if the left sublist index is less than or equal to the right sublist index, else this happens. So because the sublists are written in, so if the left sublist I is less than or equal to the right sublist j, and then that's the if, and then the else statement would be, so the else if statement in this case would be the left of I is greater than right of j. So this way is actually, so because of this, the merge sort algorithm is stable, and the way of making merge sort unstable is just removing this equal to, so it's just less than. The output in a stable algorithm, which is merge sort, so will essentially be 2, 3, 3, 4, 5, and then in the stable algorithm it will be 2, 1, 4, 3, 0. So then these would be the indices, and then this would be the output. And then in the non-stable algorithm, the output, because it will not take into account of the keys on the indexes, it'll be the same output, but instead will be 0, 2, and then this will be 4, 1, 3. So the order of these should be the other way around in a stable algorithm. Next, the last advantage is it will always run in n log n time. So a disadvantage of merge sort is the fact that it's not an in-place algorithm. So what this means is it requires ON space memory space, which is essentially the worst case space complexity, for additional array data structure. So the array data structure required in the merge function, so these new lists require extra memory space, and ON is linear. So what that means is, as the input size increases, we'll see a similar increase in terms of memory requirements. So yeah, and it additionally it also uses additional resources from to copy. So the copying of these elements into this new list requires resources to copy the elements between arrays, meaning it's much slower for larger data sets. So if we're working with a million numbers to sort compared to, say, 10 numbers to sort, so there'll be a big difference in terms of the resources required. So I will also be talking about optimization for merge sort, how to make merge sort faster. So we could, in a way, so we know that the merge sort is a recursive algorithm. So the merge sort function is recursive. So you know that from the code, merge sort here is calling sort, and that's recalling itself. So in a way, since we know that they are recursively calling themselves, we can separate this workload, these recursive calls, into different threads. So this is thread level parallelism. So this thread 1, thread 2, thread 3, thread 4, and thread and so on. So we can essentially, because when we're dividing the list of numbers, we're halving it into, we don't need to know the information of what's happening to the other lists. So thread 2 and thread 1, so these threads can have separate data, so they don't need to read data within other threads. So this way we can split the workload into multiple threads and let the recursion occur in parallel, so that merge sort is able to divide the unsorted list much quicker, and then this will definitely improve the performance, depending on the number of threads you are using. But this is something that can optimize merge sort. And also, I'd like to talk about the running time. So the time complexity of merge sort. The formula for this is T